So hi everyone, you can see this is the experimental setup for the determination of Young's modulus of a bar by single cantilever method. Okay. So here you have to find out the Young's modulus in this experiment. So here is the aim. You have to find out the Young's modulus of a material by cantilever method. You can see in this diagram also how actually the cantilever looks like. So here we require table and clamp to fix this metal strip that acts as a beam, and then loads we require. So here once again I will show you which are the apparatus we require for this experiment. So here is the clamp to fix this metal strip which acts as beam, and we can say this is the single cantilever, and support we require table. So this is the screw gauge, we can measure the thickness of the metal strip, and this is vernier caliper used to measure the breadth of the metal strip, and then these are the weight. This is weight hanger, and these are the weights we should hang at the one end of the cantilever, and then this is the scale we use to measure the length of this metal strip or the cantilever, and then we require this stopwatch to measure the oscillations, number of oscillations for each different weights when we hang at the end of the cantilever. Okay. So just once we should understand what is cantilever. So cantilever is a beam fixed horizontally at one end and loaded at the other end. Okay. So what is the formula to calculate here momentum of inertia before going to calculate Young's modulus? So here the momentum of inertia for a bar is given by B d cube by 12. Okay. And once you get the value of momentum of inertia, how you can get the B d cube by 12? Just you can write the value of B and D in the observation. I will explain you. So Young's modulus we can find out once you know the momentum of inertia of bar. Okay, 4 pi square L cube, length of the bar, into m by t square. Here weight by time period, m by t square, mean we have to take. Then you will get the Young's modulus for this experiment. So from graph also you can calculate. So experimental, theoretical you can verify. So here is the tabular column. Before going to that, first we should write the observation here. Here you should write the least count of this screw gauge, that is 0.001, and then you should write the least count of this vernier caliper. Okay, this is about 0.01 centimeter. We are not going to do this traveling microscope, not necessary. So breadth of this strip, just you can measure the breadth of this strip using this vernier caliper. Okay, then screw gauge, you can measure the thickness here. Once you measure, just write down the breadth and thickness, and then length of the bar, just you can measure here. They have done the experiment by measuring length around 92 centimeter, but here the length I am going to show you, the cantilever that we have taken. Just you can see here, it is 56 centimeter length of this bar. Okay. Next, what you have to do, then after measuring the length and breadth, you can just start the experiment. Just start with the weight around 50 gram and measure the thickness. Just I will show you the first reading here. So you can see in the tabular column, take the 5 readings for this experiment. Load applied 50, each time you have to increase 50 gram up to 250. Then time for 10 oscillations. So just I will hang here. So just you can see here, just you can measure the length of the screw gauge. So here you can keep the jaws of the screw and just measure here the breadth of the metal strip using this vernier caliper. You can just keep the jaws like here, and then you can just measure the MSR and CVD. Okay, so once you measure the MSR and CVD, least count already you know these vernier calipers, you can do the total reading here to calculate breadth of this metal strip. For the vernier calipers, they got here MSR 2.5, CVD. So MSR is what here, main scale reading, CVD how many lines coinciding, they got 2, and least count 0.01. Like that you have to measure the breadth of the metal strip. Using this screw gauge, just you have to hold this metal strip in between the jaws of this screw gauge, and then you can measure the thickness. Okay, here you can see this is the main scale reading and this is the CVD, how many lines coinciding to the main scale. Here they got 0.3 pitch scale reading, PSR. Here this is what pitch scale reading, and this is CVD. 62 into least count 0.001. Then you are going to get the thickness of the metal strip. So you can just repeat this for another 2 trials and take the average. You are going to get the breadth of the metal strip, and here also take the average for 3 readings. You will get the thickness of the metal strip. So next what you have to do here, just apply the load of 50. So here you can see I have applied the load of 50 gram at the end of the cantilever. Then you can just note down the number of oscillations here using this stopwatch. So first just you can do in the vertical direction. Okay, now I will start the stopwatch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for 10 oscillations it has taken 9 seconds. Then you should note down the time for 10 oscillations. So here for 50 gram we got 9 seconds, but for their experiment they got for 50 gram 5 seconds for 10 oscillations, and second time they got 4 seconds for the same weight 50 gram. Then you have to repeat the same procedure by applying again the 100 gram here. So each time you have to increase the weight and note down the oscillations for 10 seconds. Okay. Here for 100 gram how many seconds you will get for 10 oscillations, just write down. Similarly for 150, 200 and 250, how many oscillations, 10 oscillations, how many seconds you get, just write down here first and second. Take the mean of this. After taking mean you can calculate here time period, that is t is equal to small t by 10 second or 10 oscillations. Then you will get the time period. Take the square of this time period, t square. Then you will get in terms of 10 to the power minus 2 here. This is 0.45. So T square column you can calculate. Then go for m by T square. M is what? Mass by T square. 50 by this first reading 20.25 into 10 to the power minus 2, you will get 246.91. Repeat the same calculation for other different weights. You will get m by T square. After calculating this m by T square, you have to take the mean of all the 5 readings. Add these 5 readings and divide it by 5, you will get the mean. Okay, first what you have to do, you have to plot the graph here. So this is the graph of load 50 to 250 gram load versus T square. You will get the straight line. Take the slope ABC, a triangle AB by BC. You will get the slope here. They got 6.818. Then here already I have explained about the formulas. So momentum of inertia Ig you can calculate using the breadth, that is 2.52, and the thickness 0.345 b d cube divided by 12. Okay, Ig. After calculating the momentum of inertia Ig, they got here 862.33, and this is the Young's modulus formula, 4 pi square L cube divided by 3 Ig into m divided by T square mean. So 4 into pi square 3.142 square, and length they got here 92. Okay, then cube of the length, then Ig, momentum of inertia, that you will calculate from this breadth and thickness values b d cube by 12 formula. Then substitute the value of Ig and also m by T square mean of the first column. This is m by T square. Ig formula you can calculate by b d cube by 12. Substitute the values here. You will get the do the calculation. You will get the theoretical momentum of inertia, that is 7382314. So the value is going to be large in number, so dyne per centimeter square unit. So then at the end you can write the result here. The Young's modulus of the given bar is 738231 Newton meter per square. So this is all about the experiment on this calculation of determination of Young's modulus from the single cantilever method.